token exchange, Bitcoin exchange, options exchange. We are going to talk about fixed design issues, fixed protocol. First of all, who of you doesn't know anything about the FIX, Financial Information Exchange Protocol? Okay. FIX is something that is used to trade messages, right? Send trade messages to the exchange, and broker firms use this protocol to send exchange messages, send trade messages to the exchange to make money, profit. So, FIX is the protocol that is used worldwide for the majority of front office transactions. When I say front office transactions, I mean you are an investor and there's a brokerage firm and there's an exchange. Front office transactions are happening between the brokerage firm and the exchange. Back-end transactions, back office transactions, are the settlement, collateral transactions and things that have to do with your bank account and how much you have deposited there and whether your account covers what you're trying to trade with. Okay, so that's back office transactions. These are slow transactions, they have no latency requirements. Doesn't matter. Front office transactions, which is, anybody here heard about high frequency trading?
Excuse me.
Algorithmic trading, algorithmic trading, Wolf of Wall Street, raise your hands, Wolf of Wall Street. This is new. Okay, so Wolf of Wall Street talks about trading. Well, trading in general, but there's another movie called Boiler Room. If you watch that movie, it's talking about the market crash in 2008. That's because of high frequency traders and automated computers just trading algorithms that predict trying to make profit off really fast transactions, really fast movements in the market. So it all happens in milliseconds. So if somebody says, hey, the price is going low, I'm going to sell. There's a million machines going to sell, then the market crashes. Right? That's high frequency trading. That's the effects of high frequency trading hitting loops. That's just an introduction to what we're going to talk about today. So, the financial system infrastructure relies on FIX and a few other protocols for the back office transactions. FIX is responsible for trillions of dollars a year. That's a huge amount of money. So, we at NYBX are working on a Bitcoin exchange, and while we're looking at FIX, we discovered that it's not impossible, but it's very hard for us to use FIX because it's vulnerable, it's weak, and it costs a lot of money, human resources, endless man hours, and it's just not acceptable. And there's something that needs to happen in that industry. So we're going to talk about the FIX security design, the flaws, and what we tried to come up with in terms of another protocol stack that addresses this, and hopefully a protocol that can address front office and back office transactions. Okay, so what is the FIX protocol, Financial Information Exchange Protocol? It's three things: transport protocol, authentication protocol, or a fake authentication protocol. There's no authentication whatsoever in FIX. And a lot of engines, FIX engines. We'll talk about these in a minute. FIX now introducing protocol version 5, something called transport independence, which basically removes the transport protocol from that stack. So you can use any transport protocol you want with FIX. But there are still problems. The inherent problems in the security design of this protocol still exist, even if they get rid of transport protocol. anybody here have an idea about what latency is? Show of hands. Anybody? Anyone?
Latency over the network. Latency over the network.
Latency
as
is
in time and
well, okay, so latency over the network, it's not just about time over the network, it's about processing. So a transaction takes time to be sent, and then decomposed, deserialized, and then processed, and then a response is sent back. All of this falls under latency. It's not just traffic latency. This is a fixed security white paper released by the Fix International Limited company, that the organization responsible for fixed upgrades, the specifications of the protocol, etc. They said as a best practice, use existing technologies that sit beneath the fixed decision layer and encrypt the communications transport layer. And they highly recommend that. In a front office transaction, in high frequency trading, you cannot encrypt the transport protocol. Can anybody see the problem here? Encrypting the transport protocol immediately destroys your latency. You're done. That's end game for latency. So they lost there. And there's a reason for using ZRTP or SRTP for void communication. Because you don't want to encrypt the transport protocol, you just want to encrypt the packets, the data. In a real-time protocol, you just want to encrypt the data, not the transport protocol, because you could benefit from fragmentation to speed, routers could help you a lot, queuing, all of that stuff. You lost all of that once you encrypt the transport protocol. So I have no idea why they implement that, but so far I've found no security measure whatsoever. They just recommend to you that you should encrypt the transport protocol. And at the same time, they advertise themselves as front office protocol, financial protocol, that you could use to send, you could use algorithmic trading, automated trading, high frequency trading. Of course, that's, I don't know what to call it. So let's forget latency for now. Let's talk about a bigger issue. And please remember that what I'm talking about is transferring trillions of dollars a year. It's a huge amount of money. That's the financial system of the entire world you're looking at. So the authentication of FIX depends on two fields in the protocol, just sender comp ID and time comp ID. Honestly, I don't care what these are, but they're just simple integers that says, hey, this is the computer that I'm coming from, has an ID registered to it, and there's the target computer I'm communicating to. Now, obviously there's a strong problem with that, because one broker could say, hey, I'm broker 1, and the second broker could say, hey, I'm broker 1 too. There's nothing preventing it. Nothing whatsoever. So the solution here, of course, or what fixed designers thought was the solution is to use a fixed IP address per client and a fixed port on the server side. So now they move authentication to the networking infrastructure. Now that's a disaster, because now when you want to add clients to your business, you would have to add servers. You would have to open ports, you have to change firewalls, you would have to change hubs, virtual private networks, everything. So a single change, single customer, the onboarding process of a customer in your business costs you money. A very simple act, onboarding a user, costs you money. And of course this doesn't scale. At a certain point you cannot scale. So there are solutions implemented now by some engines that I'm going to talk about that try to work around this problem. But it's all monkey action. They're not addressing the problem at all. They're just dancing around it. So these are the main three engines that are used around the world. Appia, Cameron, and QuickFix. QuickFix is a small player compared to Appia and Cameron. These are fixed engines that basically try to fix the fixed protocol by working around the manual labor issue. So for example, I just said that in order to add a user, you have to open a port, you have to have a fixed IP address, so NAT goes out the window, and all of that has to be done manually. Now, engines step in to do that for you automatically. So all we do is basically just do the manual labor. Some of you will say, this works. And it sure does. I mean, the entire financial sector of the world is working with Fix, and it's working. There's no problem. But working with Fix is like using Telnet over SSL when you have SSH. I don't know if that analogy makes sense to you, but you should be laughing.
May I ask a question? What fixed the framework يعني ولا it's a protocol? I've never heard about it before.
Financial information exchange.
Okay.
So we exchange financial information with it. It's a protocol to exchange financial information. So if you're a broker and on an exchange, we're currently building an exchange in New York that deals with Bitcoin derivatives. So you're a broker and you want to make a trade. You issue a limit order or a market order with that exchange. So you construct a message, send it through the fixed protocol to the exchange, so the exchange could execute it, or that swap execution facility of the exchange. So there's DCO and swap execution. These are all financial terms that really don't matter to the financial exchange protocol here. That just doesn't matter. So how do we fix Fix? You just don't. You just destroy it, move it, throw it away. It doesn't work. It's done. But while I was working on LedgerX, I'm building an exchange in New York that has to do with certain interesting, unique problems that it just doesn't exist in a lot of exchanges. It has to do with architecture problems where you have online transaction processing competing with online analysis processing architecture. But that's aside from the point. I discovered that the underlying problem of Fix, and really every other protocol, is communication patterns. It's not the serialization protocol, it's not the binary protocol, it's not how fast you can serialize a message and deserialize it. It's not how fast you can communicate a message, because that doesn't matter. Everybody likes numbers, tangible objects to quantify them and scale things down to the perspective so they can measure and play with. But that doesn't help in the big picture, because you could fix latency at the serialization protocol, but you would suffer inside your exchange because of the complexity of the protocol. So you didn't do anything. It's just you move latency from here and add it somewhere else. So how do we achieve that balance between efficiency and complexity? Well, I happened to stumble upon a solution which is called Efficient Financial Message Protocol, EFM. Now, the underlying building blocks of that protocol, it's not a transport protocol, it's not serialization methods or protocols, it's none of that. Just a bunch of communication patterns. That's it. Request and error replies, publish, subscribe. Anybody here worked with publish, subscribe conventions before? So, if you think about it, it's deeper than that. If you have a communication pattern set as a requirement for a protocol or as a specification for a protocol, you're basically saying, okay, you have a piece of data, and there's a requirement, a business requirement for any kind of requirements in the protocol, or the way to price stock, that you want to send one message to a group of users. Now, that's called a publish, subscribe, and route. You have another issue where you send the one request and you receive multiple replies. So these are called communication patterns. Now, we specify communication patterns. We can build on top of them and extend that protocol. So we Now, what we use that can be tangible to you, that you can compare with against, that you can touch and play with. We've used ZeroMQ. Have anybody here heard of ZeroMQ? Okay. So ZeroMQ is a communication library or communication kernel that supports multiple communication patterns. Of course, we didn't build on top of ZeroMQ. We just found that ZeroMQ satisfies a lot of the requirements that we need. So we use ZeroMQ, which is the fastest thing I've ever seen. It competes with everything. Anybody who worked with AMQP protocols? Okay. AMQP protocols is a broker model where you have a central server, a lot of people sending messages. That server queues these messages and persists them in a database. Now, ZeroMQ is a brokerless model. There's no central server. Every client has a queue that queues these messages that they sent out, and they are queued in when you receive them. Message pack, I think some people here work with message pack, right? Anybody?
I'm not familiar with the term.
Okay, message pack is a protocol, a binary protocol. It takes objects and converts them to binary format, or compatible binary format, or standardized binary format. So the other side of the protocol can receive and deserialize an object again, so you can use it. Like for example, we have a dictionary. No, much simpler, a list, an array of integers. How would you serialize them into packets that go through the network? On the other side, you serialize them into a list again in some other programming language. You use a serialization. So if you use a serialization protocol, message pack is one that converts objects to byte streams and from byte streams to objects. Message pack particularly is very simple and it's optional, like ZeroMQ. We don't enforce particular transport protocol or serialization method. As a matter of fact, in our exchange, we use the same protocol, the same messages, over message pack and JSON. That WebSockets in ZeroMQ just doesn't matter. Once you define communication patterns, the problem simplifies a lot. Because you don't have to depend on transport protocol details. You just say, hey, this is a transport protocol. We require the transport protocol to support X, Y, and Z communication patterns. If it doesn't, bad luck. You can't work with it. You can't use it. So use pub sub, request supply patterns, pipeline patterns, and if the protocol simply happens to support them, but if your protocol supports them, then you are compatible. You can use that transport protocol with EFM. And it's a bunch of loosely coupled messages like fix. Fix depends on tons of messages. Just a message for every kind there is. At EFM, we created what we call mixins. It's a concept from Python, if you worked with that language before. Mixins are like, if I have a message that have a name and password, that's a simplification of financial messages, but normally where you have a price and the size of the contract, etc. Let's say you have a username and a password, but there are several other messages that use that same, these two fields. You don't have to say, here's username and password for every single message that requires them. You just create a mixin, right? So you just loosely coupled messages here means that you have modularized messages where you can inherit from each other. The message can inherit from each other. So how EFM, the protocol I'm working on right now, and my team, LeisureX, avoids fixed problems. How we avoid it to fall into fixed problems. Requiring the transport protocol to support required communication patterns, as I said. So you only have to require the transport protocol to support, say, pub sub. That's all you have to do. Require that specific communication pattern. And if the transport protocol proposed doesn't support that, then that's not compatible. That's it. And all of a sudden, if you look at it from an architectural perspective, when you look at the step pack and you look at the SEF and the DCO parts of your organization, like the clearinghouse and the exchange, you would see that this kind of philosophy simplifies the overall architecture of your system, because you don't have to worry about the details of the protocol. Security doesn't matter if you support logging with passwords and curve, authentication protocols, look to curve stuff. That's fine. It doesn't matter how you log in or authenticate. All matters is how you communicate these messages. Requiring support for classic CIA, trial, or communication patterns. So if your transport protocol doesn't support confidentiality, integrity, availability, you really don't want to use it in the first place. Fix doesn't support any of that.
Doesn't support?
None.
Okay.
None whatsoever. Their recommendation actually with BGP and DES. That's the cipher suite they recommend. Well, they now say it's deprecated and nobody should use it, but that's what they recommend. And it's hilariously broken. MD5 too. But there's no talk about integrity. And their authentication is hilarious. They just use 2 digits. There's no mathematical guarantee. Mathematical proof that this is authentic. This message is authentic. It's malleable. Somebody could step in and say, hey, I'm broker 2. I'm broker 5. You can't tell. Because you're tying down to that networking infrastructure. Well, let's say, hey, I don't want to use TCP, I want to use UDP. Now you have a problem. Well, not UDP, maybe I want to use multicast. And by the way, we support multicast out of the box. It's a matter of changing the 5 lines of code. Proceed, people.
May I ask? But from my understanding, I never heard about the Latency protocol. But from my understanding till now, it's being used in the currency exchange and so on, right? But I'm not
currency exchange and other types of exchanges.
Okay, very well. But how come any money is involved here, which is very sensitive, very sensitive issue? And how come the protocol that is currently deployed and being used doesn't support any kind of integrity or,
You can ask.
The question is here, why is it still being in use right now?
People don't like to change things. Okay, so you have 5 customers, brokerage firms, and you're a new exchange on the block. You're just opening for business. And these new customers coming in and saying, hey, I want to fix. It's either fix or you don't get my business. What's your options there? If you're the CEO of an exchange, what you're going to do? You're going to pick up the phone, talk to the CTO, hey, we got a support fix, you got 5 days, do it now. Now, we have a different situation because our exchange is kind of unique. We are the first, will be the first, we didn't get CFTC approval yet from the US government, but we will be the first regulated Bitcoin or virtual currencies derivatives exchange in the world. So we get to say what protocol we use. We get to put the first protocol that people use. So we don't care if you want FX because we don't care. The business sector doesn't have that. The customer base is fresh. You can tell them what they should use. But of course, we offer connectivity options. Like connectivity options is a financial industry term. It means like MPLS. Somebody could support their MPLS backend, for example. They could support VIX, multiple options. Ouch. There's a protocol called Ouch that they could support for NASDAQ exchanges. So these are alternative options. Like we do, we have connectivity options. WebSockets is one, DreamView is another. That's a connectivity option. So it's not just a matter, it's not one protocol that is supported, it's a list of protocols. And we could, in the future, support FIX if we have to. If the business requires us to support FIX, we have to support FIX. There's nothing we can do about it.
And this is what you're trying to get at by doing the EFM, right?
Yes.
Okay, very good.
Yeah, we need to destroy FIX. FIX is bad.
Okay.
So I'm trying to send a message. Basically, I'm calling for action. People, stop using FIX. It's bad for you. Okay, so what we conclude from this, the calculated protocol stacks allows for the flexibility without complexity. Basically, when you decouple, when I say decoupling protocol stack is like unlike Fix just couples everything. Tries to do authentication, tries to do transport protocol, tries to do serialization, tries to do everything. It's just, one giant protocol that tries to do everything. And that's, of course, a very bad design philosophy. So when you decouple the protocol stack, you have flexibility. You can do a lot of things. You can replace parts and put them back, and it all works. Building on top of communication patterns enables a simple shared nothing architecture. So if you start in your design with communication patterns, so not the first thing you think of is microservices or SO architecture. If you're designing a SO architecture, you would start with, I have a bunch of services and there's a hub, or a cluster like I don't know if you've heard of console or etcd, something service discovery. User service discovery where you build a lot of services and discover themselves. So if you started with components, you didn't think about it first, because you need to think about how these single components talk. What's expected? What's the expected behavior of their communication? Is it pops up? Is it pipeline? Does they just take a bunch of data and process it and then output the result? Does it maintain a session? Does it require request and reply pattern? If it does all of these things, you need to think about them first. Once you lay them down, your architecture is very simple. It just builds nicely in a shared nothing architecture. You don't have to deal with synchronization. You don't have to deal with that at all. Everything becomes asynchronous all of a sudden. EFM is a protocol that can efficiently support both front and back office transactions. That's the part where I said that we actually use JSON as a serialization format, and at the same time, well, the link is crashed. That's a surprise. Okay.
Still updates كمان.
Okay, so Windows. If we support JSON and message pack at the same time, and the way we do that is just decouple the protocol message, decouple the protocol stack. We don't require a specific serialization method. Like Fix, we can use SBE. They are trying to standardize SBE, which is simple binary encoding protocol. They're trying to do that, but that's just a stupid idea. Because they didn't fix anything, they just added more problems. I get Ouch is trying to solve the problem their own way. They're trying to invent a binary protocol that is efficient, but they didn't really solve the centralized risk in the first place, where if one thing goes down, everything goes down. Like in Fix, you have Fix hubs. Most exchanges in today's world implement hubs or virtual private networks that have huge Fix engines that process thousands of customers. And if that engine goes down, if that hub goes down, you're in trouble. You don't have, you could have full over, but there is the architecture itself is still centralized. You can't work around that. No matter, it doesn't scale. There's the concept of scalability. If the solution doesn't scale, then the problem still exists. So how to solve this is paperless models. Stop centralizing things. It's okay for people to be responsible for their own messages. And I'm talking about that. I'm working for an exchange, and the U.S. government, they have some strict regulations. For everything, you have to report to the CFTC, and that's harsh. Every little technical thing. So if you can survive that, and you can allow that clients be responsible for their own messages, I think we should do that. Instead of just throwing a broker at everything and it works. Any questions?
I think the rough target.
Can you speak up?
I think the rough target, companies that make trading engine, not the broker or the exchange. Why? Because the broker and the exchange, they don't have the decision to change or to shift from this code to another code.
Yes, they do. Well, we have that choice.
Okay, let me give you an example. I work in the Egyptian exchange. I'm in the information security department. All the brokers in Egypt connect to this FX server to the Egyptian exchange. For the reason that you said, I make security for fixed protocol. No broker can say that I am broker 1 and broker 2 because everyone connected in the tunnel and in the firewall side and in the server side, they must connect to their ports. There is many security layers from the broker to the trading engine. But the Egyptian exchange itself buy the trading engine from Nasdaq OMX. And Nasdaq OMX implement the software using fixed protocol. So the broker and the exchange use OMX software. We can change the way the OMX software works.
Well, let me ask you this. If you say that you don't have a choice, but who made the buying decision? Who said, okay, I'm buying this and this is okay with the deal?
Okay. If we compare all the trading engines worldwide, how many trading engines use fix and how many others use something?
I know what you're saying. I know that fix is the dominating protocol. And I've said already that at our exchange, we face, if a customer comes to us and says, hey, I need this connectivity option, which is fixed, we have no other option but to support it. You know, it's money. We're going to lose money if we don't. So I hear what you're saying, but what I'm trying to get at you here is deprecate, not stop using things. That's impossible. You have to, it's a gradual process. You have to start first by deprecating and then replacing it. So you can start, for example, by, NASDAQ uses Ouch protocol. They started using that because high-frequency traders prefer Ouch over Fix, because Fix is just ridiculous. And if you start offering connectivity options, and it's really, I'm not trying to sell you on a particular protocol here. I'm actually inviting you to think with me for a protocol. What do you think your use case could, add to this protocol? Can you think of something that can add to this protocol and we could work together? And we're planning at Bluekaizen actually to build a standardization community with, unlike Fix requires, proprietary licenses and paying money and stuff. We don't do that. It's open for everyone to come in and you're welcome to add that. So the problem I faced personally while building an exchange is that Fix is really seriously cripples your financial infrastructure. The design flaws in it impacts your design, impacts your architecture. I'm pretty sure you face tons of problems daily. Adding a customer, onboarding itself is very hard. Adding a new customer, the engine of course could make that for you. But imagine this, you have to notify firewalls and routes. Why? It's an application protocol, it shouldn't do that. Am I right? It shouldn't do that.
We already start to train the next generation boxes to understand the fixed protocol. One of the protocols that are not like HTTP or FTP or well-known protocols. So any security device will understand fixed protocol that is cannot scan the protocol and see if there is any malicious activity or something like that. Of course, a few devices only that can make this.
Because it's weird. I don't want to say it's stupid. Nobody, makes ties down authentication or identity problem into the network infrastructure. There's cryptography for that. That's why cryptography exists. But tying it down to the network infrastructure, I don't know. People from the 90s were funny. So, yeah, any other questions?